This video is for Unit 8 Quadrilateral Exam Review. Question number 1. We need to find the sum of the interior angles of a 82-gon, meaning that we have 82 sides in our shape. We have a formula for finding the sum of the interior angle, which is the sum of the interior angles is equal to 180 times n minus 2. 180 degrees coming from our idea of a triangle. If I take a 5-sided or 6-sided shape here, the one way we could go about doing it is dividing up our shape into triangles. So in this case, our 6-sided shape would have 1, 2, 3, 4 triangles. So if n is equal to 6, we end up having 4 triangles. This pattern repeated itself in a sense of where the number of sides there were always 2 less triangles. So to find the number of degrees inside of the 6-sided shape, I would take 180 degrees, which is the sum of the number of angles inside of a triangle, times n minus 2, where this is the number of triangles, 180 times the number of triangles. We don't want to draw an 82-sided figure, so in this particular case, instead, what we are going to do is we're just going to use the formula. So substituting in our 82 sides, giving us the sum of the interior angles is equal to 180 degrees times the quantity 82 minus 2, which gives us the sum of the interior angles being equal to 14,400 degrees. Question number 2. Once again, we are told that the sum of the interior angles of a regular n-gon is 7,380 degrees. We have to find the number of sides in this particular example. So very similar wording to question number 1, but in question number 1 we were given the number of sides and asked to find the sum. Here we're given the sum and asked to find the number of sides. So we will start off by using the same formula. The sum of the interior angles is equal to 180 times n minus 2. But now when we substitute in our known information, we know the sum is 7,380 degrees, and we're going to need to go ahead and solve for n. So we can either divide by 180 and then add 2, or distribute. I'll go ahead and distribute. 7,380 degrees equals 180 n minus 360. I'll add 360, giving us 7,740 degrees equals 180 n. So I'll divide by 180, giving us n is equal to 43 sides. On to question number 3. Find the sum. So we're finding the sum of the exterior angles this time. So the exterior angles of a regular 24-gon. So once again, we have n is equal to 24 sides. Now, we had a formula for finding the sum of the interior angles. We also have a formula for finding the sum of the exterior angles. And that is that the sum of the exterior angles is equal to 360 degrees. That's it. The sum of all the angles outside of any multi-sided shape is always going to be 360 degrees. Whether it's a 24-gon, whether it has 4 sides, whether it has a billion sides, it's always going to be 360 degrees. So we're done. Okay, next question. Question number 4. Each exterior angle of a regular n-gon has a measure of 12 degrees. So what we're given here is we're given that one exterior angle of how many sided shape we have is equal to 12 degrees. What we're asked to find is how many sides does this shape actually have? Well, we have a relationship between one exterior angle and the number of sides, or the number of sides and one exterior angle, and it is as follows. And that relationship is that in order to find one exterior angle, we take the total number of angles outside of a shape, which is 360, and divide it up equally by the number of sides. So 360 divided by n, or we could also say that the number of sides is equal to the total number of degrees, 360 degrees, divided up by the measure of just one of those exterior angles, and that'll tell me what the n value is. This is kind of like taking the average of something, the total divided by how many are there, the total divided by how many are there. So using this relationship then, if I'm trying to find the number of sides, we know that the number of sides is equal to 360 divided by one exterior angle, which in this case is 12, giving us that n is equal to 30 sides. So a 30-sided shape would have each exterior angle measure equal to 12 degrees. All right, these two formulas will be utilized in examples 5 and 6. We actually went over these together in class, but I'll go ahead and do it again. 5 and 6 are worded a little differently, but will be solved very similarly. In this case, we're given that each interior angle has a measure of 140 degrees. And we're again asked how many sides does the polygon have. So we're still looking for n, our value of the number of sides. Now, we're going to turn this problem into an exterior angle problem by using the relationship that each exterior angle plus an interior angle is equal to 180 degrees, or this idea of being supplementary. If you take a look at this five-sided shape that I've crudely drawn here, if this is my interior angle, and I extend one of the sides to actually create an exterior angle, notice that the relationship between the exterior and the interior is that they form a straight line or are supplementary. So that relationship then will help us figure out the exterior angle measure. So I can calculate my exterior angle by subtracting the interior angle from 180 degrees. So in this case, the exterior angle is equal to 180 degrees minus 140 degrees, giving me an exterior angle value of 40 degrees. Now, why is that relevant? Well, we just talked about how you can find the number of sides is related to 360 degrees divided by just one exterior angle measure. So we'll go ahead and use this exterior angle measure now. The number of sides is equal to 360 divided by 40 degrees, giving us n is equal to 9 sides. Same idea in question number 6. We are given each interior angle is 108 degrees. So I'm going to calculate the exterior angle by doing 180 degrees minus my interior angle, give me an exterior angle measure of 72 degrees. Now using my formula, the number of sides is equal to 360 divided by just one exterior angle value. N is equal to 360 divided by 72, or n is equal to 5 sides. Question number 7 and 8, again, talk directly with sum of interior angles and sum of exterior angles. We'll start with number 7. I'm given angle measures inside of a shape, so I know that the sum of those interior angles, if I added them all up, can be found by using the formula 180 degrees times n minus 2, where n is the number of sides. In this case, we count 1, 2, 3, 4, 5, 6, 7. N is equal to 7 sides. So to calculate the total, I can substitute 7 in for n, but I also am going to go ahead and add up all of these angle measures inside, because that should be equal to whatever the value the formula gives me. Meaning that if I were to add up all of the angles inside, x plus 161 plus 128 plus x plus 11 plus 123 plus 165 plus 102, that answer should be equal to me finding the value of 180 times 7 minus 2, the total sum inside of the shape. So let's combine like terms and simplify here. 2x plus 690 degrees is equal to 900 degrees from our formula. We'll subtract 690 and divide by 2, giving us an answer of x is equal to 105. Question number 8, very similar. We can add up all of the angles outside of a shape, and they should be equal to 360 degrees. So when I add all of these angles together, it should equal a value of 360. 70 plus 60 plus 65 plus 40 plus y should be equal to 360 degrees. Combining like terms, y plus 235 equals 360, or y is equal to 125. This page dealing with section 29, sum of interior and exterior angle measures. Expect a bunch of these on the quiz test.